Hey guys, welcome. My name is Carlos Anguiano and I am your friendly neighborhood technical director. So in this first video, I wanted to create something for some of you guys that want to learn how to use Python inside of a DCC application such as 3D Studio Max. But the majority of the video is actually not going to be Mac specific. So a lot of the stuff that I'll be showing you guys in this video will actually kind of apply to any DCC application that you want to work with. So this could potentially be getting started with Python with any DCC app. We're going to be downloading Python 3. We're going to be downloading Eclipse, which is my IDE of choice. We're going to be set up PyDev, which is an extension for Eclipse, which allows us to do all the fancy stuff that we want to do in Python. And then we're going to do a really simple Eclipse setup where we're going to set up formatting and analysis rules. We're also going to be linking Eclipse to this program called a linter. In this particular case, we're going to use PyLint. And that basically looks for mistakes and issues in our code and actually teaches us how to be better coders. And then we're going to take a quick look at some simple testing setups that you can set up in Eclipse that allow you to test your code. And people, technical directors, don't do this enough. They don't write tests for their code and actually make sure that their code is working. And one of the really cool things with Eclipse is that it actually integrates really well with some of the testing tools that are available for Python that allow you to do automatic testing. And I know what you're thinking, like if I'm going to be coding in Python for this application, why would I want to have Python 3? And the reason is because we really want to set up our environment in a way in which we can learn Python outside of the DCC and we can have like a really good IDE. For those of you that don't know, an IDE is an integrated development environment, which is basically like a text editor or on steroids with a lot of really cool features that allow you to just develop really fast and do really cool things that you can't do anywhere else, right? So by setting up this Python 3 standalone, we'll be able to actually set up like this really cool, fully featured learning environment where we'll be able to like learn and practice all of our Python skills. And then transitioning to the DC app is going to be super easy. So we're gonna get started. We're gonna install Python 3 first. I think that I've cleared my machine for most of the garbage that I have that would get in the way of sort of showing you guys how to do this from scratch. So I'm going to go to python.org, and we're not actually going to get the latest version of Python 3. We will be working on Python 3 because if you guys don't know, Python 2.7, which is what we've been using in the industry for years, is now officially dead. And in the next year or so, all of the DCC apps are going to start actually having to support Python 3. So that's just because basically Python 2.7 is dead. It's done. It's not going to be around anymore. So we got to move into it. So if you're one of these guys that wrote a bunch of 2.7 code and now has to try to support 3.7 and you didn't write your code to work on both from the very beginning, then I feel bad for you. Good luck. I hope you are able to transition. Okay, so we're gonna go to downloads and we're gonna go, actually let me just go to the home page and we'll kind of navigate from scratch. So I'm going to actually go to Windows, on the downloads Windows, and then we're going to find a version that we want. So actually 3.7 sounds good. I think that's what I'm using at work, so that's what I'm going to be using here. 3.7.5, yes, that's October 15th, only a few weeks ago. So yeah, let's stick to that just for good luck. So now that I'm in the 3.7.5 page, you want to go all the way down to the bottom and you want to make sure that you actually download the correct executable for Python, because there's a few of them, and the one that you want is the one that has 64. You want to make sure that you get Python 64 so that when you install any third-party libraries that we use throughout this, that you can actually have the 64 version, 64-bit version of the libraries. Alright, so we're gonna download this now. I'm gonna go to my downloads. They should all be ready to go. Boom, boom, boom. Let's double click this. Now there's a few things that I personally like to do in my installation to make sure that things are not getting in the way, that I don't accidentally break something. So I'm actually going to do a custom installation. I'm going to install documentation, install pip, definitely install pip. That's how you will get third-party libraries very easily into Python. We're gonna add the test suite. Pilot launcher, I don't care. I am going to do it for all users. Create a shortcut for installed applications. Nah, I'm good. Add Python to environment variables. Definitely don't do this part. I personally like to manage all of this by hand, especially if I'm running different versions of Python, or if like I'm writing tools that are going to work across multiple DCCs. I don't want to pollute the environment. I basically want to control that all on my own. And other than that, add Python to environment variables, pre-compile standard libraries, download debugging symbols, download. No, we're pretty good. So this is it. The only other thing that I'm going to do is that I actually don't like installing this under my user folder. I think that's pretty bad practice. So I'm actually going to install everything into C Python 3.7. This is how Python 2.7 used to install, and I actually like this. So I'll do this for now. So let's just go ahead and get that installed. All right, very good. So we have Python 3 now. So if we double click Python, hey, there we go. One thing that we want to make sure, just to test that it wasn't actually accidentally added to the environment, is that I usually like to open a DOS window, type Python, and basically it should crash. It shouldn't find it. If it finds Python, this could potentially get in the way later, because as I said, you want to control where your programs find Python, especially if you end up having to manage multiple versions and stuff like that. You don't want Windows dictating that. So this is really good. This is really good that I open a DOS window, and when I type Python, nothing happens. It doesn't actually find it. Alright, cool. So the next thing that we want to do is that we're going to download the latest version of Eclipse, which is my favorite IDE. But actually, before we do this, I think this is the thing that trips people the most with Eclipse. Eclipse is not actually originally made for Python. It's actually made to work in Java, but it supports many languages. So you can actually use Eclipse for Python, you can use it for C++, you can use it to do web development, you can use it for like a ton of things. But since it's originally kind of IDE that was kind of originally for Java, you need to have, if you want to have the Java development environment installed, because it requires it, even though you'll never actually use it when doing Python development. And this gets really tricky because Oracle recently changed their licensing. So usually, one of the cool things is that since Eclipse is free and Eclipse requires it, they actually started an open source version of the JDK. So, and actually, let me start this from scratch so that you guys see where I'm going for all of this. So I'm going to eclipse.org, and then I'm going to go to projects, and here I'm going to hit search. So here I'm going to do a quick search for JDK in the Eclipse website. Here we go, Eclipse OpenJ9. So really weird name, but this is basically what you need. You're gonna need to install this before you actually can do anything with Eclipse. Eclipse Open, and this is actually my first time using this particular implementation. So hopefully it goes well. So we're gonna use OpenJDK OpenJ9. So yeah, let's use that version 8. That's fine. OpenJDK 8, sure. Latest release, sure. Alright, I'm just gonna do a default installation, and then we'll see where things go from there. Very cool. So now that I've done that, I'm gonna go back to eclipse.org, and we're actually gonna get the Eclipse IDE now. And of course, since Eclipse works for like a million things, the process is not like really any more clear. But I'll show you usually what I download. So I just went to eclipse.org, I hit the download button, and I'm literally just doing the universal installer. And this is gonna give me like basically like a bunch of like different options of things that I can of flavors of Eclipse that I can download for my development. Alright, so Eclipse installer will open this up. Hopefully it works. If you get any errors at this point, is because of the OpenJDK. That part's missing. So if you have any issues, I don't know, just leave a comment on the video. I'll try to get back to you if I see it, maybe try to give you some help. Anyways, I think recently I've been kind of using the Eclipse IDE for C++ developers. It just seems to be like the one that confuses me the less. So that's kind of the one that I've sort of been sticking to. It seems like if I'm JDK, awesome, cool. And like, check this out. It actually is pulling the adopt OpenJDK. So this is great. This means that I'm using the free one, and I don't need to worry about goofy freaking installation and licensing issues later. So I like that. I'm gonna change my install environment a little bit. I like the fact that it's putting it under _ IDE, and that it's giving me the version of the IDE, but like I actually want to put it in the Eclipse folder. This way, if later on I want to upgrade my IDE, I can simply just, you know, have it kind of like all under one folder. We're going to agree to a bunch of stuff. Okay, we're gonna agree to a lot more stuff. Always accept certificates. Sure, what is this? Select all. There we go. Hey, look, awesome. So it looks like Eclipse for C and C++ developers has been installed, and now I can actually launch it, and I should be inside of my favorite place on earth, the Eclipse IDE. But there's one more thing we gotta do before we get straight into Python and Python development. So one of the things that Eclipse does that's kind of nice, and a lot of IDEs kind of do this, is that they allow you to sort of like have different folders where you host projects. So that's the first thing that Eclipse is going to ask you, is basically like, where do you want to host your first project? And I'm actually not quite ready to tell it that, because I need to do some setup in Python first to set up my first project where I'm going to be doing most of my development. And in order to do that, we're going to go back and we're going to use a little bit of DOS here, and we are going to install our first third-party software on top of Python. And usually I refer these to TPS. So if you hear me say I'm going to install some TPS, just know that TPS stands for third-party software. In case you guys have ever watched the movie Office Space and you guys hear the guys making fun of TPS reports, TPS is third-party software. It took me forever to figure that out. But anyways, just a fun little joke. Alright, very cool. So we're going to open up the command prompt, and from here I am going to go to my Python directory, Python 3.7, perfect. And so in this directory, there's a really cool application that allows you to install things inside of Python. Anything that you might need, you need to install PySide, you need to install NumPy, anything that you need, you can basically use this program. And this program is called pip, and it's inside of the scripts folder, pip, and pip. There we go, it was a typo. All right, so if we type pip, just like that, pipxc, and we'll run it, we see all of the help for pip. So we're only going to install one thing in this particular flavor of Python, and that's a script called VirtualEnv. And the reason why we're going to do this is because one of the big mistakes that I made when I first got started with all of this is that I would just install Python, and then I would just pip install everything, NumPy, PySide, blah, blah, blah. And then I had multiple projects that I had to work on, and my Python interpreter was one big bloated Python interpreter, and it was really hard to kind of like just add the parts that I needed for the specific project that I was working on, because like one Python parser basically had everything, and that was really sucky. And there was also other times where maybe I wanted to use a slightly different version of a TPS on a particular project, and I couldn't, because once again I would have to upgrade every single project, right? So instead of like just adding everything on to this particular Python parser, what we're gonna do is that we're gonna install only one thing called VirtualEnv, and then that allows us to create like little Python virtual environments that almost look like a separate Python installer, where we can actually then in very granular detail just install the things that we need. We're gonna do that real quick. That's really easy. We're gonna use pip, and we're gonna say install VirtualEnv. Oh, maybe if I spell it right, VirtualEnv. Oh, okay, so it's actually already installed, so that's really good. And then I just want to point into the folder where I want to actually create my first project, and this is basically where I'm going to point Eclipse to. So I'm going to create a folder in my C drive called like Python YouTube projects. And this is basically where we're going to just kind of host projects that we create for this channel. So I'm going to basically say VirtualEnv exe, Python YouTube projects, and then I'm going to just say just our base project. We'll have like a base project that we have here. And we're going to do that. And that's pretty much it. This is now going to create a very fancy base project folder in here. Is going to sort of link the Python interpreter that is here to this particular folder, and then it's going to give us a new pip installer that we can use to push TPS that only this particular base project is. But anyways, we're gonna leave that alone. We're gonna come back to VirtualEnvs because now I actually have something that I can point my Eclipse to. So let's get back to Eclipse. Alright, and now we are 100% inside a completely vanilla installation of the Eclipse IDE. So one of the first things that I like to hit is this little button right here. That just kind of sets up my windows in a default way. This panel over here on the side is where you're usually going to see like all your packages and your folders and all of that stuff. We're not going to worry about that right now because we need to actually install the PyDev extension for Eclipse that then actually gives us all the cool features of working with Python in Eclipse. So let's do that next. I'm going to go ahead and close welcome, the welcome tab. Then I'm going to go into help and I'm going to go directly into the Eclipse marketplace. And then in here, it's all very simple, really. We're just going to do a search for PyDev. Very good, and top search, right? So we're gonna hit install, and then we're basically just gonna turn everything on and agree to a bunch of stuff that we're not gonna read. And then this basically just starts installing PyDev for us. And you can see down here is where it's doing all of that. And at some point, of course, it's gonna ask us to restart Eclipse. Okay, so we're back in Eclipse, and even though we can't see anything different, we can actually now start working in Python. So one of the things that's really interesting about Eclipse is that Eclipse has this idea of views, and views are kind of like configurations for Eclipse that are specific to tasks. So for example, you might have a Java view or you might have a C++ view, and in this case what we need to set up the PyDev view, and that's super simple. Right now the default view is this button here. As you can tell, the default view right now is set up to C and C++. So what we're gonna do is that we're actually gonna click here. I'm sorry, they're not called views, they're called perspective. I don't know what I was thinking. Anyways, we're gonna hit the plus here and we're gonna open up our perspective window, and then you should be able to see PyDev. So that's the one that we want. We're gonna click on that sucker. We're gonna cross a welcome widget, and now we just have this cool little icon that says PyDev. I'm actually not going to be programming C or C++, so I can click on that C perspective and I can close it. So now I'm 100% inside of PyDev. This is great. So the next thing that I want to do is that I want to actually create a project. So I'm going to click over here on the Package Explorer and I'm going to say project, and then under general project, under PyDev, we're just going to create a regular PyDev project. And this is where we're going to start pointing things around. So as you can tell, because Eclipse already knows where I'm working on, all I have to do is give it a project name, and that's where it's going to create kind of like my first folder package. So I'm going to call this my first, and actually let's do Pepe convention. So I'll do my first project. The next thing that we want to do is that we're gonna then configure Eclipse to actually find our Python 3 interpreter. So the thing that we have to do is we have to say configure the interpreter, and we're gonna do a manual configuration. This will open this screen that will actually allow us to browse to our Python exe, which is going to be inside of our Python YouTube's base project. Inside of here, you can actually go to scripts, and you will find a Python exe. So remember that this is linked to our original one, and this is the reason why we're pulling Python from exe versus just pulling it from the original place where we install it, because remember, this is the virtual environment, so it's all linked, right? So we're gonna click here, and then as soon as we do that, we're gonna say okay, and then we're basically gonna add Python YouTube base project, lib scripts, DLLs. We'll just leave this default. We won't worry too much about that. And now we're pretty much good to go. We can actually start doing Python coding right now. Well, maybe not right now, but once this is done configuring. All right, so now we're going to allow access to Eclipse. Eclipse wants to do stuff. Always let Eclipse do stuff. And now that we have that configuration, we're just gonna say finish, and then boom, we have a Python environment ready to rock and roll. I can actually click here and I can create my first Python module. So the name of my module is just going to be typical hello world. Hit finish, and boom, I've added my first Python file. These are some cool templates that you can use for, I usually just use the default one, or I close it or whatever, but it's kind of like little boilerplate stuff that it puts in there. That's kind of neat. You get that for free. So let's say we're gonna do like our classic sort of hello world example. All right, very cool. And then inside of our main function, we're just gonna execute hello world. And if you click here, it will actually run your code. and here we see a little console pops up, and now it prints hello world. So pretty easy. We downloaded Python, we downloaded Eclipse, and we installed PyDev, we set up a project, and now we can actually start coding in Python standalone. Look at you, man. You're making great progress. I'm proud of you. Anyway, so let's look at some of the cool features that we have now that we're in PyDev, now that we're in IDE. Why did we go through all the trouble of setting this up? Well, some cool stuff that I like about this, about using an IDE, is some of the options that it gives us. So if I go here to preferences, I'm going to turn a couple of things on that I usually just always turn on in Eclipse. In classic Python fashion, we're going to make sure that insert spaces for tabs is turned on. And also, I think I already have show line numbers. That's great. I personally like to see white spaces, so I turn that on, and then I go to configure visibility, and I turn everything off other than spaces. And I find this to be very useful because it allows me to see indentation errors in my code really easily, or it allows me to see when somebody snuck in like a tab symbol or something crazy like that. So I'll hit OK, and then I believe that in this part, that's it. So let's go ahead and hit apply on that, and you see here, I start seeing those nice little dots. So I think that that's really good stuff. The next thing that I want to do is I'm going to get out of general now, and we're actually going to go to the PyDev menu, and we're going to start turning on some of those cool features. So we're going to go to the editor, and the first thing I'm going to do is, I'm not a big fan of auto imports, so I'm going to turn that off. So basically, auto imports is you'll start typing something, and if it's not currently defined in your file, it will try to like magically guess where it needs to import it from. It sucks. Turn it off. Don't use it. Do auto import on organization imports. Yeah, we can turn that off. Just basically, we're not going to use any of those features. Code analysis, however, we are going to use, and this is something that is super, super cool. This is basically stuff where like we can sort of say what our basic code styling is going to be, and Python and Eclipse will actually sort of like give us warnings and mark up our code to tell us things that we could improve or things that don't meet convention. Now, if you ever worked in any kind of programming environment, especially in visual effects or video games where you're actually doing programming, one of the biggest fights that you'll ever have with your team is just code styling fights. What should you name your variables? What should you do camel case or uppercase or blah 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 blah. One of the beautiful things about Python that not a lot of people in our industry know is that there's actually like a universal styling guide for Python that's already kind of been established and a lot of people had agreed upon. So it's all kind of mute. And the cool thing about there being this like kind of official style language is that you can actually just tell your IDE that this is the official style, that you want to follow the official style, and your IDE will kind of help you follow it. It'll kind of do most of the things for you, and the things that it can't do for you, it will kind of just highlight for you. So that's something that's really cool. So that is PEP 8. And I know people that know me probably are looking at this video now and being like, Carlos, you're just a hypocrite. You fought PEP 8 for so long. And you know what? I did. And now I'm just defeated. And while I don't agree with some of this shit, hey, at least I don't have to argue with you about it anymore. Yeah, you know who you are. So we're gonna click in here. We wanna make sure that this is default imports, that's default, that's pretty good. And then here we go. Py code style PEP 8. Notice that it's currently disabled. I'm actually gonna turn it on so that I do get PEP 8 warnings. So obviously this is kind of nonsense code. This is not supposed to make sense, but I'm trying to type something so that I can save and see if my auto formatter is kicking in. So this is the first thing that we catch. So this is actually really cool. So this is part of PEP 8 standards, right? Which is that it actually detects that here I'm using a symbol that's already reserved. I'm using this thing called type, and that's a command that already exists in Python. So immediately the IDE is letting me know, thing type, you might want to name it something else. So that's the beginning of basically doing code analysis. There is another really cool code analysis tool called PyLint that really gets, it's like very detailed. But the thing that I really like about PyLint is that it enforces PEP 8 conventions, but it also enforces a bunch of other conventions that like you wouldn't know about it, but like it actually teaches you how to code Python better. So in order to get Pylint working, it's really simple. We're gonna have to install Pylint via pip. But unlike VirtualEnv, we're not going to install it in the original place where we installed Python 3. We're going to install it on our virtual environment. Let's clear that. And then in here I have scripts. So when working with a VirtualEnv, this is one thing that you have to know, so pay attention for this. So when you're working inside your VirtualEnv, one of the things that you have to do in order to install software for it is that you first have to activate it. So now that I'm in that folder that I created using VirtualEnv, I can go to scripts and there's a batch file in there called activate. So if I run this, notice that now my DOS prompts change just slightly, right? Now I have this thing called base project. And the thing that's cool about this is, check this out. I can now actually still do stuff like Python, and it opens a Python interpreter. Before, remember when we first installed Python, this didn't work. It didn't work because we never added Python to our environment. But with the VirtualEnv, by activating it inside of a DOS prompt, it effectively makes this particular virtual environment the Python. And all of a sudden DOS knows about it. And so it will also know the pip that's in there, but it will know that I'm using the one inside of this virtual environment and not the one that I set up globally. So that's very important. Remember, create your virtual environment, and then when you're ready to install stuff, run the activate script to actually switch and make that virtual environment active, and then you can run a Python that's dedicated to that project, and you can run a pip that installs TPS only to that particular version of Python. So we're going to install install Pylint. And this is our awesome linter. So now if I go to scripts after this is done, you will realize I now have this Pylint exe. So this is really awesome. It's really simple to set up. We're going to go to preferences, and under code analysis there's a Pylint menu. We're going to say use Pylint, but we are going to specify where Pylint lives. And notice that immediately jumped us to our scripts here. And we can click on Pylint, open, and I usually just set all of them to warnings. This is going to be really heavy, so there's going to be a couple of rules that you might want to basically disable, and for that I will show you guys later how to basically link a text file where you can put sort of like what rules to skip and what rules not to apply, so that you can actually customize. So you don't have to do all of the page, you don't have to do every single Pylint function. You can actually set up these little text files, disable the ones that you run into that you don't necessarily agree with. Alright, cool. So we're gonna say apply and close, and I'm gonna give you an example. So Pepe convention is very strict on how you name basically like variables and methods and stuff like that, right? So for example, Pepe convention dictates that methods would actually be lowercase separated by underscores. So if I do like a camel case, something like that, technically this doesn't fit Pepe convention. So let's look at the warnings that I'm getting here, and look at this. Now we get Pylint. So one is telling me a few things. I don't have a doc string. We'll talk about doc strings and documenting your code later. But it also says function name camel case method doesn't conform to snake case naming style, right? So it's letting me know right off the bat I'm not following a styling guide. If you guys are lucky enough to work at a place that does code reviews, this might actually help you fix it before somebody points it out. Hey man, your code sucks. You're not following Pepe standard. Pfft, what are you doing? By the way, if you come from C or C++, you're probably looking at this and saying like, that's not, camel case is real coding, man. What are you doing? But for you guys, shut up. I don't want to hear it. So that's very simple code analysis that allows you to basically, before you even commit your code, like just get some ideas of how good your code is. Some of the things that I really like about this is things that teach me more about Python. Cool, so this is a good example. I've kind of showed another example. It's like a lot of people coming from MaxScript or other languages are used to kind of doing, if not something in, test list or test collection, do something, right? But PyDev actually teaches us that while this is common, Python actually much rather have a more readable version, right? So in here we can say, Pylint is telling us, consider changing not key in to key not in. And this is something that at first drove me crazy because I didn't think it was that big of a deal, but I have to admit that after using it for a while, it actually makes better code. Do not use len sequence without comparison to determine if a sequence is empty. So it's basically letting me know, dude, like you don't need to do this. You can simply do this. Right? So this is one of the things that I love about Pylint, is that it actually teaches me how to do better coding. So another thing that we might notice is like as I'm messing around with this, there's like a bunch of other errors that are just like little formatting things, right? So for example, blank line contains white spaces. If you follow PyDev conventions, you shouldn't have spaces in blank lines. That's just part of their convention. But like, you know, I don't want to go in here and change all of this stuff, like every single thing line by line. So, but the cool thing is that I don't have to. PyDev actually comes with an auto formatter that's really awesome that knows about the styling guide, and every time I save the file, it will actually perform some of these formatting operations for me. Let's go into code formatter. Awesome. We're gonna say auto pep 8 because we're following pep 8 standards. The other thing that I want to do is that I'm actually going to change the quotation marks to double quotes for doc strings. And as I said, we'll talk about doc strings later. Doc strings are something that are very useful if you set up a TPS called Sphinx that will create beautiful documentation based on documentation strings, aka doc strings, that you just build into your code. So you can literally look at your code, the comments that you put in your code, and create beautiful documentation. And those are doc strings, and we will cover those at a later video. So anyways, quotation marks, great. Code formatter, this is pretty much it. That's all we're gonna do. I think that we're gonna look into the save actions real quick. So we're gonna say apply save actions only to files in workspace. Auto format editor content before saving. Yes, I personally like that. I do like saying sort imports on save. You can do the update date field. I think that's this guy up here. I don't think that that's ever really worked for me, but hey, you know, try it out, go for it, let me know. Maybe if you can get it working, you can leave me a comment and tell me how you got it to work. Code style interface, delete unused imports. I wouldn't do that. Combine from imports whenever possible. Sort, I always turn on all the sorting. I find that this is kind of a funny one at work. We don't always use the same sorting stuff, so when somebody commits code and then you diff it, like you kind of get things that change but don't really affect the code simply because we're not all using the same sorting options. Thing to keep in mind, maybe use the same sorting options that the rest of your coworkers. They might appreciate that. Bad coworker, you know who you are. So we're gonna hit apply close, and so now in order to format our document in a beautiful way, we actually should be able to just save it, and boom, all of a sudden a bunch of our formatting issues that PyLint and pep8 were detecting are actually gone now. There's one more thing that I wanted to show you guys, which is super cool about PyDev, and it has to do with testing. So let's do some testing. For you guys that maybe have a little bit more experience in Python, you might know about this really cool Python library called unit test. What unit test is basically a testing library, and it's excellent. And if you don't know about it, like, tell me in the comments and I'll make some more tutorials to show you how to test your code using unit test. It's phenomenal and you should use it. Alright, here we go. So my test is happening, it's passing, but it's basically just printing 6 because 1, 2, and 3 all summed together equals 6. But printing it is not really good enough because I have to look at it, right? But what if I know, like obviously I know that cool sum, if I put 1, 2, and 3, the return's always gonna be 6, right? So I can basically say something like self assert true val equals 6, right? And so if I run this, my test is just gonna run and nothing's gonna fail because this is true, right? But what happens if I introduce a bug, like I accidentally do something like this, right? So if I change my function and I introduce a bug like this, where technically for some reason there's another digit that I'm slipping in there, this is no longer gonna be correct, right? I'm gonna give it 1, 2, and 3, but the result's actually gonna be 7, which is correct, which is not correct, right? And so knowing that the intended design of this function is to return 6 when 1, 2, and 3 are supplied to it, we're gonna be able to catch this error, right? So sure enough, because I've introduced a bug into my code, whenever I run this test now, I get this assert true val equals 6, false is not true. So the thing that's really awesome about this, and the reason why I'm showing you this, is because PyDev fully integrates into this. And let's see, we're gonna write a couple of tests, just empty tests that will just always pass, right? And check this out, this is really cool because it says it ran 3 out of 3 and only 1 failed, and it actually tells me which one failed, and I can actually jump to that guy from here. So when you've written 150 tests and have amazing coverage, because that's what we do, guys, right? We always test our code and we always have ultimate coverage over all of our code base because we're the friendly neighborhood technical director. But anyways, when your test list gets really long, this is something that's really nice because you can see you can make sure that all of your tests ran, but it will only show you the ones that fail, and then it'll actually allow you to jump to the particular test and test lines that failed. So really cool tool if you do testing, which god damn it, you should do testing, because now instead of just relying on this tons of messages from the console, you actually have something really nice that allows you to jump up across all those different tests. And to finish this, the thing that's the most awesome is this. Check this out. We're actually gonna fix our bug, and we can choose to just run the one test that failed. And boom, now everything works. Only one test ran, but it was the test that had actually failed before. And now, if I run all of this again, then we see that we get this beautiful, perfect harmony of 3 tests that ran with 0 failures. Anyways, guys, that's my time for today. Hopefully you found this useful. I'm gonna try to make another video next that maybe shows some debugging so that you guys can see some other really cool debugging features that Eclipse has. And maybe in that video we can also maybe look at writing some code in Eclipse that is actually DCC dependent, and how we could possibly use Max and remote debugging in Eclipse to actually debug that. Debuggers are so awesome. I will marry one day. That's it for today. Tell me, guys, how did you guys enjoy this video? Do you guys want to see more of this type of content? Is there a particular sort of technical art questions that you guys have for me? Is there a particular type of code example that you would like to see? Would you like to see more videos about testing your code? Yeah, I'm sure everybody wants to see more videos about testing their code. That makes a lot of sense. You know, you tell me, do you want to learn how to interact with databases? Do you want to learn how to build a web app? Believe it or not, we do those type of things as technical artists and technical directors. We do that type of stuff, or at least I do. I don't know what you do. You guys, give me a thumbs up, subscribe, hit the bell. You know what to do. It's YouTube. You've been doing it for a while. Just follow it, man. Yeah, hopefully I'll see you guys in the next video. All right. Peace out, y'all.